Formula 10 J-1, liquid circuit board formula, container 1, solar panel cell, AC, container 2, for now showing functionalities in Hyper H2 extraction. So for the Formula 2, you'll notice that it's already begun to bubble rapidly. You see how hot it's getting already? The thermal energy is off the hook. It's already getting to the point where it's going to begin to evaporate at high rage. So just bear with me. The green color has to do with the trap, but I'll get into all that later. Damn dog. Just gotta let this sit for a little bit. Ouch. It'll begin to reach the boiling point here very soon. Technically, it kind of already has. You can see some of the steam evaporation off of it. But it's going to begin to start rapidly boiling, and these bubbles for H2 and O2 are going to get a lot larger. So for DC, it's 60 to 80% electrical conductivity, which separates the molecule H2 from O2, and it produces about 1 kilogram an hour or so, depending upon the regulatory conduction. For AC, however, it's a lot more because it's higher intense volumes of energy to allow it to begin the process of hyper extraction. Of course, the liquid solar panel right now, AC cell, is still a little unstable because it's bubbling profusely around the wires, but that's just part of the process. But I thought I would give you a little glimpse into the differentiaries between the solar AC cell and the liquid circuit board cell. Which, by the way, this has silicon in it now with photon conversion. This has no silicon in it at all, period, whatsoever. I know it's turning into a majestic emerald green color, which is perfect for a cell like this. Also, keynote that the water back here, it is backlogging a portion of water all the way down the line and allowing it to drip. So this does extract water this way, right there, on the edge, right there. There you go. All right, back to here. And now you can see the steam evaporation rate, or the H2 evaporation rate, has increased, and not to mention the fluctuation in thermal energy and bubbling has profusely, quote-unquote, continued. This is going to get rage boiling here in a minute. So if I left this on for 25 minutes or 15 minutes, it would completely evaporate the entire cell. It still reconfigures. This still has all functionalities to Formula 10 J1, as this is the circuit board, obviously. There we go. Starting to kick up now. It's taking a few more minutes. And don't mind the orangish color, it's from the wire. I have to scrape out the impurities periodically because I'm doing this in a smaller container. As you can tell, it's really beginning to bubble, especially on this corner over here. Now you can see it really beginning to hyper extract. This is what I was referring to. Since there is no technical limit on the amount of energy that can be passed in here, I can literally extract as much as I want through thermal heat, which is 250 liters depending upon volume of heat and so on. Okay, so as you can tell, this one isn't very stable. However, the circuit board, which this will reach stability, is 100% stable. In fact, you will see no bubbles, or hardly any bubbles in the system as it begins to quote-unquote get to that point.
Do you want to stop the video?
No, keep going. Just give it a minute. As you can tell, it's taking quite a long time for this jar to get excruciatingly hot. The thermal backflow prevention is in here right now. The second set of multi-molecular dividers, the other additional 9 and all that. But as you can tell, the differentiaries between the two cells is that this one still needs to become more stable. And really the only real way to do that is to add more of this back in here. Even though it's a little darker now, you'll notice that it's not too bubbly everywhere anymore. So that it's completely stable this way.